this video, we're going to take a look at the slope of a tangent line. Also, we'll take a look at the slope of a secant line using some algebra kinds of ideas. And so, remember the slope between any 2 points is the change in y over change in x. So for our secant line, our second y value is f of x plus delta x. Our first y value is f of x. And so our slope is f of x plus delta x minus f of x all over x plus delta x. Right? It's a difference between our two x values, x plus delta x minus x. And so on bottom, the x values, those will cancel, and so we're left with f of x plus delta x on top minus f of x. And on bottom, we're left with just delta x. So that's the slope between the slope of a secant line. Between 2 points, you need two distinctly different points. For a tangent line, we start thinking about what is the slope at a single point. And so as we start to look at the slope at a single point, we're taking the idea of a secant line, but we're letting that denominator, that delta x, we're letting that go to 0. So we're going to use this idea of a limit that we've talked about before when we define the slope of a secant line through a single point. And so our slope here, m, is going to be the limit as delta x approaches 0 of our secant slope, right? So x plus f of x plus delta x minus f of x all over delta x. So that's the slope of our secant line. Right. So let's go through, so we're letting that value of delta x go to 0. Right. So let's maybe take a look at an example. Right. So we'll take a look at an example here. We're going to estimate this numerically. Right. So we are going to look at our function x squared minus 1 at the point 2, 3. So let's graph our function. Right. So it's a parabola. It's opening up. Right. Has a vertex at 0, -1. Right, just like this. Here at 2, we are interested in what's the slope at 2, 3. Right, so right at that point, what is our slope? And so we're going to estimate this numerically by choosing values that are a little bit more than 2. Right, so first we will choose a value that is 0.1 units above 2. Right. So 2.1. If we think about that point, we're going to find the point, the slope between 2, 3 and 2.1, and then the function value at 2.1. Right? And so what is that function value at 2.1? That function value is 3.41. You get that by plugging 2.1 into our original function f of x. Right? So let's plot a rough idea of this here. So somewhere up here we have that. And so we're finding the slope of the line between those 2 points. All right, so to find that slope, we're going to take the difference in the y values divided by the difference in the x values. So we have 3.41 minus 3 over 2.1. Right? So change in y values over change in x values, 2.1 minus 2. And when we do that, we get 0.41 divided by 0.1, which is 4.1. That is the slope between those 2 points where we have the point 2, 3, the point we're interested in, and then a point that is 0.1 delta x, 0.1 u away from it. All right, so 2.1. Now if we take that delta x to be a little bit smaller, right, so let's delta x be 2.01, right, delta x is 0.01. the function value at 2.01, its function value is 3.0401, right? So that's what we would get if we plugged in 2.01 into that original function f of x equals x squared minus 1, right? So that's where we get our 3.0401, and we're just finding the slope between that point and 2 comma 3. So we'll take the change in the y values, 3.0401 minus 3 over 2.01, right? The second x value minus 2. And that should, so we're looking at the slope between this same point, so that 2 comma 3, that's the point we're approaching. We're only going to change the second point every time. Right? And so we're using 2.01 as the x value for our second point. And when we find the slope, we get 4.01. And if we continue this process for our next couple of values, we get 4.001. And then we're going to get 4.0001. So if we look at that, it looks like those slopes are getting closer and closer to 4 as that value of delta x is getting closer and closer to 0. So we could say the slope of the tangent line, it's 4. In our next video, we're going to take a look at another example of this. We will see you there.